Okay, guys, welcome. Today we're going to talk about applications of quadratic equations. Really what we mean by this is just word problems, right? So the first type of word problem that we're going to look at requires a little bit of an extra explanation, and that's the idea of a combined work problem, right? Now, what we mean by a combined work problem is suppose that you have two people working on a project, right? Um, so there's sort of three things that you can consider. You can consider how long it would take for person one to complete the project by himself, how long it would take the person two to complete the project by themselves, and then also if both of them work together, how long could it take for them to complete the project, right? Now that relation is defined by this formula here, right? So if you have the time that it takes for the first person or the first object, if you have like a machine or something, to complete the job, the time it takes for the second object to complete the job, and the time for both, we can relate it by this formula. All right, so that's what we're going to do here. So in part A, we're told that working together, two cranes can unload a ship in 4 hours, right? So time together is 4 hours, right? Now we also know that the slower crane, if it works alone, requires 6 hours more than the faster crane to do the job. So we could say that maybe X is the speed, or let's not say speed, let's say the time for the fast crane. Then we know that X plus 6 is the time for the slow crane. All right, and we want to know how long does it take for each crane to do the job by itself. So we want to find X and we want to find X plus 6. So now using our formula that we just talked about, we can say that this is 1 over X plus 1 over X plus 6, and that equals 1 over 4. Okay, so now, of course, this is just a rational equation, so we're going to multiply both sides by the LCD. And it looks like our LCD is a 4 times X times an X plus 6. So now if we multiply, so in the first term on the left, my X's will cancel, and I'll be left with a 4 times X plus 6 times 1, but I'm not going to write 1, plus, and then I get a 4 times X because the X plus 6's will cancel. And then on the right, the 4's cancel, and I'm left with X times an X plus 6. So now if we distribute this and simplify, we're going to get a 4X plus 24 plus 4X is equal to an X squared plus 6X. Well, now since we see that we have a quadratic, let's move everything to one side. So if I subtract, well, first of all, these two 4X's would give me 8X. And then if I subtract this over and subtract the 24 over, we're going to get 0 is equal to X squared minus 2X minus 24. Well, it looks like we can factor this one, right? So we can think of this as an X and an X here. What are two numbers that multiply to negative 24 and add to a negative 2? Well, we get minus 6 and plus 4. And this, of course, tells me that X minus 6 is 0, or X plus 4 is 0. And this tells me that X is 6, and this tells me X is equal to negative 4. Now, of course, one of these answers doesn't make sense, right? We would, of course, throw out this one because we don't want to have a negative time, right? So now remember, X was the time for the fast crane. So it takes 6 hours for the fast crane to do the job by itself. And X plus 6 is the slow crane. So that's 6 plus 6, so that's 12 hours. Right, so it would take the slow crane 12 hours to do it by itself, and the fast crane 6 hours. Okay. Now for part B, we have that a storage tank can be filled in 6 hours when 2 pipes are used. So together is 6 hours. Okay. Now we have that the larger diameter pipe used alone requires 5 hours less to fill the tank than the smaller diameter pipe. So we can say that the largest pipe is x minus 5 as long as the small pipe is x. All right, and then we set this up the same way. This is 1 over x plus 1 over x minus 5 is equal to 1 over 6. All right, so now we multiply both sides by the LCD. So that would be a 6x times x minus 5. And if we do that, we're going to get in the first equation, or sorry, in the first term, the x's will cancel and be left with a 6 times x minus 5. In the second one, the x minus 5's will cancel. And then that will give us an x times x minus 5. So then we get 6x minus 30 plus 6x is equal to x squared minus 5x. So same as before, I can think of these as 12x, and then we'll move everything over. So then we get an x squared minus 17x plus 30 is equal to 0. So let me give myself a little more room. So we can factor this as an x minus 15, x minus 2 is equal to 0. And we get that x is equal to 15 and x is equal to 2. All right. Now before it's not obvious which, like before we had the negative and it was obvious which answer was no good. But here it's not as obvious. But if we go back and we look, we see that the time that it takes for them to do the job together is 6 hours, right? So this x equals 15 is not possible, right? So we're going to throw that one out, right? So then we get, oh, sorry, wait a minute. Maybe we do want, yeah, we don't want 2. I'm sorry. Right, because then we're saying that it would take less time for it to do it by itself, which clearly doesn't make sense. So we want x is equal to 15, right? Now x equals the small pipe. So that's 15. And x minus 5 is the large pipe, right? So that's a 15 minus 5, so a 10. And I think both of these were in hours again. Yeah, so sorry about that. Yeah, the 2 doesn't make sense here because then you're saying the small pipe by itself does it in 2 hours when both working together takes 6 hours, and that doesn't make sense. Okay, so those are some combined work problems. Those are interesting. Okay. In example 2, we have that the length of a pool is 3 times its width, and the pool is surrounded by a grass walk 4 feet wide. The area of the region consisting of the pool and the walk is 684 square feet. Find the dimensions of the pool. So let's first draw this out. So we have this, this rectangular pool here, and we have a pool that's surrounded by this grass walkway, right? So this is all grass. Okay, now we know that the length of a pool is 3 times its width. So let's call the width x, and then the length is 3 times the width, so that's 3x. Right? And then we also know that the pool is surrounded by a grass walk that is 4 feet wide. So then we have from here to here is 4 feet. Right? Now we know that the area of the entire region is 684 square feet. Entire region. Right? Well, the entire region is not 3x times x. We need this length times this length. Right? Well, if the walk is 4 feet wide, then on this side we have the x from the pool and a 4 and a 4. So it looks like the width of the entire region is x plus 8. right? And then by the same logic, the length is 3x plus 8, right? Because you're adding 4 on each side. So now 684, the area of the entire region, is x plus 8 times 3x plus 8. So now if we multiply this out, we're going to get 684 is equal to a 3x squared plus an 8x plus a 24x, and then we get a plus a 64. Right? So this is going to give us, let's subtract 684 while we're at it. And then we get that 0 is equal to 3x squared plus a 32x. And let's see, if we do 64 minus 684, we should get a minus 620. Okay. So now in this case, it's not entirely obvious what this would factor to, if it can be factored. So let's go ahead and we'll use the quadratic formula. Let's go ahead and we'll do that. So if we use the quadratic formula, actually let's use, no, that's fine. We'll use quadratic formula. So we get x equals negative b plus or minus b squared minus 4ac all over 2a. So I'm going to get a negative 32 plus or minus. Now 32 squared, let's see, let me pull that up on my calculator. 32 squared will give us a 1024, sorry, minus 4ac, so a 4 times 3 times 620, and we're adding this now, so a plus 7440 over 2 times a, so over a 6. Okay, so it looks like we're going to get a negative 32 over 6 plus or minus, let's see, square root of 7440 plus 1024 will give us a square root of 8464. And let's see, does that give us a perfect square root? Yes, it does. So we're going to get negative 32 plus or minus a 92 over 6. So it looks like for x, we're going to get a negative 32 plus 92 would be a 60 over 6. So we get a 10. And if we subtract 92, we're going to get a minus 124 over 6. And of course, this won't make sense, but just for completeness, this is going to be negative 20 and 2/3. Right? But again, we can't have negative length. Right? So it looks like we get that x, which was our width, is 10, and then 3x, which is our length, would be 3 times 10, which would be 30. Okay. Now part B, we have that the altitude of a triangle is 2 centimeters less than its base. All right, so let's again just draw this out. So we have a triangle and its altitude, so from here to here, is 2 less than the base. So if I make the altitude x minus 2, the base is x. Right? So if the area of the triangle is 24 square centimeters, we want to find the base and the altitude. Right? So we know that the area is 24. Right? Well, the area of a triangle is 1/2 base times height. So we have 24 is equal to 1/2 x times x minus 2. Now, of course, let's get rid of the fraction and multiply both sides by 2. So we get a 48 is equal to x squared minus 2x. So if we move the 48 over, we get an x squared minus 2x minus 48 is equal to 0. And of course, we can factor this as an x minus 6, x plus, x plus 6, x minus 8, right? Equals 0. So we get x is either negative 6 or x equals 8. And of course, we're going to take the positive version, right? We're going to take x equals 8. So then that tells us that the base is 8 and the altitude is 2 because it's x minus 2. So it's 6. Okay. So let's look at the next example. So in example 3, we have that the larger of two numbers exceeds the smaller by 2. And if the sum of the squares of the two numbers is 74, we want to find the two numbers, right? So here we're going to use a system of equations. We know that if we let x equal the smaller number and y equal the larger number, then we can find both of these, right? So the first sentence tells us that the larger of the two numbers exceeds the smaller by 2. So we know that y is equal to x plus 2, right? The larger exceeds the smaller by 2. So I take the smaller and I add 2, I get the larger number. The next sentence tells me that if I look at the sum of the squares, I get 74. So that tells me that 74 is equal to x squared plus y squared, right? Well, now I can take y, which is x plus 2, and I can plug that in for this y. So now I have 74 equals x squared plus y, which is x plus 2 squared. So I'm going to get 74 is equal to x squared. And once I distribute this out, I'm going to get an x squared plus 4x plus 4. So if I move the 74 over and combine like terms, we're going to get that 0 is equal to 2x squared plus a 4x minus a 70. All right, so let's factor a 2 out and let's make our life a little easier. So we're going to get 0 is equal to 2 times an x squared plus 2x minus 35. And I can divide both sides by 2, and that's not going to change the problem. And now we can factor. We're going to get an x plus 7, x minus 5 is equal to 0. So we get x is negative 7, and x is equal to 5. And of course, we want x equals 5 here, right? Because we know, actually not necessarily, right? So I guess we could have, since we have sum of squares, it actually could be either of the two. So let's see. So if x is 5, then that makes the larger number, which was x plus 2, we get x is equal to, y is equal to 7. Right? If you choose your x to be negative 7, then you get that your y is a negative 5. Right? So both of those examples, you have that the larger is bigger than the smaller by 2, and then if you add those squares, you're going to get 74. So actually, both of those answers would technically work. Okay, let's look at part B. Oops. Okay, so let me put this back in here. Y equals negative 5. So in part B, we have that the sum of a number and its reciprocal is 17 over 4. We want to find the number. So if I take x and I add it to its reciprocal, which is 1 over x, I get 1 over 74. Let me make sure I got that right. Yep. Okay, so we want to find the number. So now, of course, here we have an equation with fractions, so let's multiply both sides by the LCD. So in this case, that's 74x. Right, so if we do that, we're going to get a 74x squared, and then plus a 74, and then we get a x on this side. Right? So now if we subtract x from both sides, we get 74x squared minus x plus 74 is equal to 0, all right, which is what we want. Now, for this one, let's see, so there's not really a clear way that we can factor this, right? Because then you'd have to do 74 times 74. So let's do completing the square. So let's move 74 over. And then we have 74x squared minus x is equal to negative 74. Now we'll factor out the 74. And then we're going to need an x over 74 here. Well, now if we divide both sides by 74, we'll get x squared minus x over 74 is equal to negative 1. Okay, so now what's my b? Well, my b is negative 1 over 74. So my b over 2 is a negative 1 over 74 times 2, or 148. And if I square negative 1 over 148, I'm going to get that this is a 1 over a 2, 1904. So now if I add that to both sides, I'm going to have x squared minus x over 74 plus 1 over 2, 1904 is equal to negative 1 plus 1 over 2, 1904. So now on the left side, I can factor this as a perfect square, right? So this is going to become now x minus 1 over 148. Oops. Must accidentally hit the home button. Okay, so let's see, where was I? Oh, here we go. Okay, so let's bring this back. Okay, so back to where we were. We can factor this as an x minus 1 over 148 squared. And then if I add the left and if I add this negative 1 and the 1 over 2, 1904, I'm really doing negative 21904 plus 1. So I'm going to get a negative 21903 over 21904. And then if we square root both sides, we're going to get that x minus 1 over 148 is equal to plus or minus 21903. And remember, we said that 148 squared was 21904, so this is now 148 again. Since we have the negative. And now we just need to add 148. So we're going to get that x is equal to 1 over 148 plus or minus square root of 21903 over 148 times I. All right, so that's our answer for that one. Okay, so that one was a little bit tricky. Okay, did I write down the right number? Oh, it was 17 over 4, so that would probably make it easier. But anyway, that's what it would be for that. Let's do the actual problem real quick, just so that that's complete. So x plus 1 over x, if I did 17 over 4, right, that would be much easier. Because now we just need to multiply both sides by 4x. So we get a 4x squared plus 4 is equal to a 17x. So now if I move the 17x over, minus 17x plus 4 is equal to 0. Now this we can factor much easier. This is 4x squared minus 16x minus x plus 4, right? Because if you do 4 times 4, you're going to get a 16. If you do negative 16 times negative 1, you will get 16. If you add them, you get negative 17. So now if we factor by grouping, I can take a 4x out. I'll get an x minus 4 Then I can take a 1 out and I'll get an x minus 4. So I'm going to get x minus 4 times a 4x minus 1 is equal to 0. So now I'm going to get that this is x is equal to 4, and this is x is equal to 1/4. And of course, this is what we expect because 4 and 1/4 are reciprocals, right? So if I choose my x to be 4 or 1/4, both of those would work, right? So of course, that was certainly much easier than 1/74. But if you wanted to do 1/74, that's how you would do it. Okay, so I believe this is the last example in this section. In part A, we have that an investor purchased a number of shares of stock for a total of 600. So now we are told that if the investor had paid $2 less per share, the number of shares that could have been purchased for the same amount of money would have increased by 10. We want to know how many shares were bought. Okay, so we know that we want to make X the number of shares, right? And we'll say that P is the price per share. Right? So this first equation, we purchased a number of shares of stock for 600. So that tells us that price per share times number of shares was 600. Right? Now, we know that in the second equation, if the investor had paid $2 less per share, so instead if the price were P minus 2, right, then the number of shares that we could have purchased for the same amount of money would have increased by 10. So we would have gotten the number of shares plus 10, and that would still equal 600. Right? So now sort of a sneaky thing that we can do is that rather than solve for X and evaluate, both of these things are equal to 600. So why not just set them equal? So we can say that P times X is equal to P minus 2. Actually, we won't be able to do that, right? Because we'll still have two variables. So let's not do that. Right, so let's go ahead. Let's instead, we'll solve this first one for X, let's say. So then we get that X is equal to 600 over P. So now if we plug this into here, we're going to get that P minus 2 times 600 over P plus 10 is equal to 600. So now if we FOIL, we're going to get P times 600 over P is just 600. Then we're going to get a plus 10P minus a 1200 over P, and then minus 20 is equal to 600. Well, we can subtract 600 from both sides. That's not a problem. And then we end up with 10P minus 1200 over P minus 20 is equal to 0. Right? So if we multiply both sides by P, we can get rid of the fraction. And we get a 10P squared minus 1200 minus 20P. And if we reorder this and factor out a 10, divide both sides by 10, right? We're going to get a P squared minus 2P minus 120 is equal to 0. Right? So now are there two numbers that if we multiply them together give us a minus 120 and add to negative 2? Right? So it's possible that we could factor this in something like this. Right? So now if you look at 120, it's not at all obvious right away what numbers we should use. So let's maybe do completing the square. So if we add 120 to both sides, we're going to get P squared minus 2P is equal to 0. And if I add B over 2 squared, B over 2 is just negative 1. If I square that, that's still 1. This is 120. And then I need to add 1 here. So I'm going to get that P squared. Actually, let's factor it. So we get a P minus 1 squared is equal to 121. So now if we square root both sides, we get that P minus 1 is equal to plus or minus 11. And then if we add 1 to both sides, we get P is equal to 1 plus or minus 11. So we get either P is equal to 12 or P is equal to negative 10, right? And of course, in this case, the negative doesn't make sense again. So we would take that P is equal to 12. So that means that the price per share was 12. So now we still need to figure out how many shares were bought, right? But we know that since PX is equal to 600, and we know that P is now 12, we have that 12x is equal to 600, so divide both sides by 12. And this would give you that x is equal to 50. So that 50 shares were bought. Okay. And finally, in part B, we have that a business machine dealer purchased a number of used printing calculators at an auction for a total expenditure of $240. Right? After giving one of the calculators to his daughter, he sold the remaining calculators at a profit of 15 each for a profit of 35 on the entire transaction. We want to know how many printing calculators did he buy. So we need to know two things. We have two unknown things right now, right? We need to know calculators bought and we need to know how much he sold each one for. Okay. So let's see. So we have that after giving one of his calculators to his daughter, he sold the remaining calculators at a profit of $15 each for a profit of $35 on the entire transaction. So we know that if he gave one to his daughter, then he sold X minus one of them because he gave one to his daughter. Right? And we actually probably even need another variable here, right? We need to say that, well, actually, let's put it this way. Let's say that this is each one that he bought for, right? So he originally bought Y times X calculators, and that was for a total expenditure of $240. Right? And then after he gave one to his daughter, so he did X minus one, he sold each one for a profit of $15, right? So he bought each one for some amount of money and he sold it for $15 more. And that gave him a profit of $35, right? So that gave him $240 plus 35, so that gave him $275. Right? Because we need to still have a $35 profit, so that would be $275 minus $240. All right, well now similarly in the last one, we can solve this one for X. We get that X is 240 over Y. So now if we plug that in, we get that 240 over Y minus 1 times Y plus 15 is 275. So we need to factor this. Oops. Okay, so the first thing that we need to do is once we FOIL, we're going to get a 240, and let's see, 240 times 15 is going to give us a 3,600, so we're going to get a plus 3,600 over Y. Then we're going to get minus Y, and then we're going to get a minus 15 equals 275. Well, this 240 and this minus 15 will give me a 225. So if I subtract 225, we get this now 3,600 over Y minus Y is equal to 50. Now we can multiply both sides by Y, and we get that 3,600 minus y squared is equal to 50y. So now if we bring everything to one side, we can say that y squared plus 50y minus 3600 is equal to 0, right? So now are there two numbers that multiply to 3600 and then add to 50? So you can think about this almost as like you're multiplying to 36, but they need to add to 5, right? So can we do that? So if we multiply to 36, we could do something like, let's see. So we could do 12 and 3. We could do 9 and 4, right? So if we do a plus 90 and a minus 40, that should do it, right? Because then they add to 50 and they multiply to 3600. So we get y is equal to negative 90 from this one, and y is equal to 40 from this one. And of course, we want the positive answer. So if y is equal to 40, we can find x by this equation. So if we divide both sides by 40, we get that x is equal to 6. So it looks like he bought 6 calculators, and he originally bought them for $40 each, right? So that's that one. Okay, so that concludes this video on applications of quadratics. I hope you enjoyed, and I will see you next time.